Easy BTech, your guide for BTech and beyond. In the today's topic, we will discuss about operating point and DC load line analysis for a BJT transistor. Okay, students, very important topic. Okay, today we will start it. See, importance of operating point. Okay. Now, what we know about biasing? Biasing. Faithful output. Faithful output of an amplifier. The faithful output of an amplifier, or distortion free output of an amplifier is due to applied input voltage, that is input signal voltage, and values of resistance. Okay, if this input voltage is sufficient and resistance is sufficient, then the operating point is at fixed point. Operating point is fixed. Okay, this is we discuss in detail. Okay, now to get a faithful amplification, it means a distortion free output. The signal output depends upon only the applied input voltage and its resistance, and we will draw a line between the output current versus output voltage. That line is known as a DC load line. A line is drawn between IC current and output voltage is known as load line. Okay. Now suppose you can take a common emitter configuration. For a common emitter configuration, the output response may be like this. Okay. Now, the transistor, if you take a common emitter configuration, we have capacitor, resistor is RB, PCC, RC, this is an amplifier circuit. You can apply input across here. Now, to write these input equations for DC analysis, frequency is 0, that is Xc is equal to 1 by j omega c, 1 by 2 pi fc. The frequency 0, 1 by 0, infinity. Okay, for DC analysis, capacitor will act as open circuit. Capacitor will act as a open circuit. Okay. Now we will write this expression as an expressions VCC. We will write this as an equation KVL across the output side. VCC is equal to ICRC plus VCE, and IC, this loop we will write as VCC is equal to IBRB plus VBE. From this we will find the value of IB, and IC also we may find it. Okay, it is an equation 1, equation 2. From equation 1, we will write this. Suppose the graphic may see here this. Now this is an IC, this is VC. The output characteristics of common emitter, output characteristics. Okay, what is an output characteristics? A plot can be drawn between output current and output voltage by keeping input current constant. Okay, students, now you can clearly see. Now from the equation 1, that is VCC is equal to ICRC plus VCE. Now at this point, you clearly see at this point, that is from this equation, if VCE is 0, if VCE is 0, if VCE is 0 means what happens? VCC is equal to ICRC. From this, if you write on the x-axis, this is an x-axis and this is an y-axis. Okay, we will write IC is equal to VCC by RC. Okay, that we will see here clearly. Okay, now we will write VCC is equal to ICRC plus VCE, as VCE is 0 at the point. At VCE is 0, then we will write VCC is equal to ICRC. Then we will write IC is equal to VCC by RC. Okay, by knowing the value of RC and VCC, we will get the value of IC current. We will get the value of IC current. Okay, in this graph. This is an IC, this is an VCE, and the graph is like this. This is about input current constant. Okay, now we will draw the line. This is from this graph, IC is equal to VCC by RC by keeping VCE 0. Then this point, at this point. Okay, now from the equation 1, from this equation, VCC is equal to ICRC plus VCE. On the x-axis, IC is 0. By substituting this, we will get VCC is equal to VCE. Now this is at this point. Now if you draw the line in between these two, okay, you are drawing a line in between these two lines. This value is VCC by RC. This value is VCE is equal to VCC. Okay. Now this line is called as a DC load line. Now exert the center. This is a point. Exert the center. This is a point. From this point and this point we will call as a VCEQ, and this point I will call as an ICQ, and this point we will write here VCEQ comma ICQ. Okay. This point is known as Q point. Q point or operating point. A line is drawn between y-axis, that is IC current, and x-axis, that is VCE. Okay. Now the intersection of this point, intersection of IC and VCE. Intersection of IC and VCE is known as DC load line. Okay. Next. The intersection point on the load line is known as operating point. For a faithful operation, the operating point is selected exactly at the center. To get distortion free output signal. To get distortion free output of a signal. That point we will call as VCEQ and ICQ. VCEQ and ICQ. Okay. This line, this point is known as this is nothing but a load line. This is nothing but an operating point or a Q point. Operating point or a Q point. Okay, this is known as a load line analysis. Similarly, for AC supply, or if you draw an AC load line, for AC load line analysis, what we have to take? Similarly, in the same manner, what we can draw the structure. This is IC, this is VCE, and the output of a waveform is like this. This is IC, this is VCE. It's a load line, and this point this is ICQ, VCQ. This point we'll call as a Q point or operating point. For an AC load line analysis, we may consider that the output voltage RAC is equal to RC parallel to RL. That is, you can see here, this RC and RL will becomes parallel, RC parallel to RL, by considering the AC signal. Now we can draw the load line analysis. We can draw the load line without touching the Q point. We may draw the load line analysis. We may draw in this manner. This point and this point. This AB is a DC load line, C and D. This is a this A and B is a DC load line. This is C and D is known as a AB DC load line. CD is an AC load line. To get these equations, we may write VCE is equal to VCEQ operating point plus ICQ into RAC. That is VCEQ plus ICQ into RC parallel to RL. You will get the value of VCQ, a load line on the x-axis. That is a D point. Similarly, by touching by touching operating point, by touching the operating point. Similarly, ICQ, IC is equal to ICQ plus VCQ by RAC. IC is equal to ICQ plus RAC. That is ICQ plus VCQ plus RC parallel to RL. Okay. This point on the y-axis. Okay, that you can see in the previous. This point, this point, this IC, and this point. Okay, this is an AC load line. It is an AC load line between C and D, and DC load line between A and B. Okay, students, this is a load line analysis for the BJT transistor. Thank you. Easy BTech guide for BTech and BI. Hello students, now we will discuss that this is the DC and AC load line analysis. Now we will discuss how the with an example we will discuss how we will connect both how we can draw both AC and DC load line. How we can draw AC and DC load line. Okay, now you can see for a given, you can see in a transistor amplifier, in a transistor amplifier circuit, we have this RC is 8 kilo ohm and VCC is 24 volts and load resistance is, that is RL is equal to 24 kilo ohm. Now he has a given in the problem, you have to draw DC and AC load line. First you can see from this, to draw that equation we know VCC is equal to ICRC plus VCE. Okay. From this already to get on y-axis, IC is equal to VCC by RC. VCC is how much? 24 kilo ohm volts and RC has given 8 kilo ohm. Now 8 3s are 24 and kilo will go up, you will get 3 milliamperes. The value of current IC is equal to 3 milliamperes for the point A. Okay. Similarly, from this equation, to get on x-axis, that is IC is 0. By substituting this, we will get VCC is equal to VCE is equal to 24 volts. Okay, this we have drawn for the DC load line, for an DC load line. DC load line. Now here, this is an IC, this is an VCE. It has given IC. IC is equal to 24 by 8 kilo. That is, we are getting milliamperes, 3 milliamperes. Now at one point, okay, this point we are assuming it is a 3 milliamperes on the y-axis. On the x-axis we are getting 24. This we are getting 24. Now we will draw the straight line between this. And this point we will call as a Q point. Q point is exactly intersecting this point and this point. This point we will call as a ICQ, and this we will call as a VCEQ. This is for a DC load line. This is for DC load line. From the given problem, if you want to find AC load line analysis, AC load line, what we have to do? The formula for that is IC is equal to ICQ plus you will get a VCEQ by RC parallel to RL, and VCE is equal to VCEQ plus ICQ into RC parallel to RL. This is the value we are getting. Now exactly from the center, what we will get? VCE is equal to VCQ is equal to VCC by 2. That we will get as 24 by 2. We will get 12 volts. And ICQ, the similar manner, we will get ICQ. ICQ is equal to, we are getting 3 milliampere by 2. You will get 1.5 milliampere. Okay, students. Now this value is divided by 2, that is 1.5 milliampere. This Q point value is 1.5 milliampere, comma 12 volts is the value of Q point. Similarly, to get the formula, IC we will write IC is equal to ICQ from this formula. ICQ is 1.5 milliampere plus VCEQ, that is 12 by RC parallel to RL. RC parallel to RL. Now what is the value of RC? 8. RL 24 by 8 plus 24. Okay, this value you are getting this the value of RC parallel to RL, approximately you are getting like a 6 kilo ohm, because it is 8 kilo. You will get some value, and 8 plus 20, it is kilo. Here 10 power 6, here kilo. Cancel and you will make in kilo. And these two, some relation, you will get 6 kilo ohm. Now the value, that is 6 kilo ohm. 6 kilo ohm. Kilo will go up, it will become milli. It means 12s. Now we will get the value of IC is 3.5 milliampere. 2 plus 1.5. Now it will be somewhere at this point. This is 3.5 milliampere. And we get VCE VCE is equal to VCE is equal to VCQ. VCQ is 12. 12 plus ICQ. ICQ is 1.5. 1.5 into 10 power minus 3. RC parallel to RL, that is 6 kilo ohm. This kilo and this will get cancelled. 6. Okay. Now you will get this value. You will get this value, that is 21 volts. The value, by substituting this value, you will get 21 volts. Okay, now it is 1.5 into 6. 1.5 into 6. 6 5 is 30. You will get 9 volts. 9 plus 12, 21 volts. Now it will be at this point. It is 24, it is 21. Now we are drawing a line between this. We are drawing a line between this. Drawing a line here. Now this 3 milli, this is 21 volts. Okay, this is 12 volts, this is 1.5 volts. Now it is this line. Yellow line is a DC load line and green line is an AC load line. Okay, the operating point is not shifting, it is at exact this point. Okay, if the operating point shift up and bottom, the faithful you cannot get faithful operation. A noise can be built within the circuit. Okay, students.